All right, so in section 4.4b, we're going to talk about reference angles. And we have the definition first here. It says, let theta be an angle in standard position meaning on the x-axis opening up, that lies in a quadrant. It can be in any quadrant. Its reference angle, though, is going to be the positive angle. That right there is going to be the most important. Reference angles always have to be the positive angles. And we're going to name that theta with the slash up above. So theta apostrophe. That is what that says right there. Please make sure that you see that difference. Okay, so one is just theta. The other one we can call arc theta if we want to stick to a name. Let's call that arc theta. All right. Formed by the terminal side theta and the x-axis. So we're always going to be referencing the x-axis when we talk about reference angles. So if you think about the x-axis, it's a full 180 degrees. It's 180 on this left-hand side. When you talk about your y-axis, it's 180 on the left side. But when we get to the right side, we're now talking about 360 degrees. So keep that in mind as well as we talk about reference angles. All right. So then we go into the steps. So find a positive angle theta less than 360 degrees, so it has to be between 0 and 360, or 0 and 2 pi, that is coterminal with the given angle. We've talked about coterminal angles. They share the same standard position side, the same initial side, and then they can be however many rotations around the circle. Then we need to draw theta in standard position, and then use the drawing to find the reference angle for the given angle. The positive acute angle formed by the terminal side of arc theta, and the x-axis is the reference angle. All right, lots of information. We're going to go quadrant by quadrant first, and then we have about 8 or so questions to go through on the second page. All right, so in the first quadrant, we're going to talk about some angles, so I'm going to just draw in an angle here. Of course, we have our initial side first, followed by our terminal side. This is going to be called our theta. That's my angle that I'm drawing. The great thing about our first quadrant is that our theta angle and our reference angle are going to be the exact same. There's no changes in that one because it's coming straight off of the x-axis already, and it's already a positive angle. So there's no changes. That's what I'm going to say here. Reference angle and the angle theta are the same. So if we ever have an angle in the first quadrant, we don't have to worry about finding its reference angle. It's going to be the exact same no matter what. All right. In quadrant 2, however, let's draw an angle that opens up into quadrant 2. So I have my initial side followed by my terminal side. And this entire angle that opens up from the initial side is going to be my theta. Now the reference angle, however, is going to be from the x-axis. That's where the x-axis comes in. And that's going to be your reference. So I'm going to say theta arc theta. There's a difference. One of them is a full opening up into the second quadrant. The other one, however, is going to start at the 180 degrees and move in, and that's going to help us determine the function to solve for that. So if we're talking about degrees, in order to find what my arc theta value is going to be, my reference angle, it's going to be 180 degrees first minus whatever my original theta was to begin with. And that will give me my answer in degrees. You're starting at your 180 first. And then by subtracting 180, that's going to leave me with a positive angle at the end. So make sure that your reference angle always ends up being positive. That's why we do 180 first and then subtract. If we took our value and then subtracted 180, we're going to end up with a negative angle, and that's not allowed. If I'm talking about radians, however, Instead of 180 degrees, we're going to talk about pi and then subtract our theta from that. So the only difference between degrees and radians is if you're using 180 or if we're using pi. Again, you will know which one to use based off of whatever our theta is. If I tell you theta is, I don't know, 100 degrees, then we know we're going to use the degrees calculation. However, if I tell you that theta is actually, let's see, something in quadrant 2, 2 pi over 3, then we're going to use the radians. It all depends on what theta is like when it's given to you. So pay close attention to that as we go into page 2 on our notes. So let's go down to quadrant 3 and quadrant 4. Same kind of idea. I'm going to draw my first one. So in quadrant 3, I'm opening on the initial side, and it's going to go all the way into quadrant 3 down here. Just doing a quick sketch. This is representing my theta. All right, this is the trickiest one that I struggle with, so we got to remember what's what. Reference angles are always referring to the x-axis. So the closest x-axis to this angle right here is this side here. So that's going to be the remaining piece for our reference angle. We're taking that axis at 180 degrees and then moving it down to that terminal side on my initial angle. However, remember, we want our reference angle to be positive. So this time, you're going to take the original theta. If I'm calculating for my reference, your original theta minus 180 degrees. And again, think about that. If my original theta is more than 180 degrees, because it's in the third quadrant, the only way to keep a positive angle out of that is to subtract 180. And then I'll still have a positive angle out of that. Similarly, if I want it in radians, I'm going to take my original theta, that's in radians, and I'm going to subtract pi. Okay, the key is to remember you always want a positive answer at the end when we're talking about reference angles. Quadrant 4, same initial side, going to open all the way up into quadrant 4. And so your theta is represented by this entire red almost circle. But this time our arc theta, our reference angle, is going from this x-axis down to your terminal side. So they always share a terminal side, but they're going to be the other direction, if you will. All right. Again, remember, we can't have our reference angles being negative, so I can't just take the negative version of that knowing it's opening down. I have to first, to find my calculation, I'm going to first take 360, the entire circle, and then I'm going to subtract whatever that theta was. And by doing that, I will still end up with a positive angle. Same thing for radians. This time, though, I'm going to have 2 pi, and then I'm going to subtract whatever my original angle was. All right. By doing this, your answer will always end up positive. That is the goal. So on page 2, we can use page 1 as a reference. Keep that handy. Page 2, we're going to solve and figure out some reference angles based off of what we're given. All right. So it says find the reference angle for each of the following angles. Well, before we get started, we need to remember that our angles, our initial angles, need to be positive. That's one rule. I can't find the reference unless I'm talking about positive angles to begin with. And then, by doing the reference angle, I know that my final answer has to be between 0 and technically 180. Oh my goodness, and 180. And you'll see that be the case every single time. That's kind of like a hint as to what we're aiming for. So let's do question 1 together. If I were to graph 345 degrees, I'm going to know that that's going to fall in the 4th quadrant. Okay, so I can go up and remind myself, well, in the 4th quadrant, I was given degrees, so I'm going to use this first function here because it's going to keep my answer in degrees. And it tells me to take a full circle, 360, and then subtract the angle we were given, 345. And that's all I need to do for question 1. Take the original 360 circle, subtract the 345 degrees that we were given, and my final answer as the reference angle is 15 degrees. All right, we don't have to convert to radians at all because we were given degrees. Whatever you were given, stick to that same format. That's key. And of course, I should be more specific here. I would say arc theta, or our reference angle, equals 15 degrees, just to be specific. All right. For question 2, we have negative 135 degrees, but we have to remember that we can't find reference angles unless they're already started as positive. So I'm going to remember the coterminal angles. That's where that section comes into play here. The coterminal angle to negative 135 is telling me that I need to add a rotation. So I'm going to add 360 degrees. And by adding 360 degrees, I'm going to end up with 225 degrees. Now remember, that was just an added step because we need to have a positive angle so that we can refer later. All right, so now with 225 degrees, I know that that's going to be in the 3rd quadrant. So the 3rd quadrant has to deal with pi this time. And it's a little bit more than pi, or a little bit more than 180 degrees. So if I want to keep my reference angle positive, I'm going to have to subtract that 180 degrees after what I have. So I'm going to have my reference angle equals 225 minus 180. And if you look back at the first page, you will see that that is what we want to do. We'll have reference angle equals, and that will come out to give us a positive 45 degrees. And we're good to continue. You're finding the reference angle directly 180 degrees away every single time. 580 degrees does not fall between 0 and 360, so I want to find the coterminal angle first. This time I want to subtract a full circle so that I can get it between 0 and 360. That's going to give me 220 degrees, which is indeed, again, in the 3rd quadrant. 3rd quadrant tells me to take my theta, my original value, and subtract 180 again. So my final answer will be 40 degrees. All right. 4th question, again, we want it to be between 0 and 360, so I'm going to add a rotation. That's going to give me a positive 120 degrees, which this time will fall in the 2nd quadrant. My reference angle to 120 degrees is going to first be 180 minus 120. That will give me 60 degrees as my reference angle. Continuing on. This time I'm in radians. Questions 5 through 8 are in radians, so I have to make sure I'm using 2 pi or pi in my scenarios. So 5 pi over 6, you guys technically actually don't know this yet, but 5 pi over 6, if you were to think about this really quick, you know that 6 pi over 6 is the same as pi, but this isn't quite 6 pi over 6, this is only 5 pi, so it's not really past pi, it's just shy of pi. So by knowing that little bit of detail, we can say that this falls in the 2nd quadrant. It's pretty close to the x-axis, but it's not quite there. So now I'm going to use the same steps. I take my reference angle, and I'm going to say, well, what is pi minus the angle I was given, 5 pi over 6. Remember, when we have fractions, we need to have the same denominator. So that's 6 pi over 6 minus 5 pi over 6. So my final value for my reference angle is going to be pi over 6. Okay, the only thing I want us to master as we go through these notes, especially with radians, because we aren't too familiar with radians quite yet, just master when are we subtracting 180, when are we adding 180, what are we doing with 360, what are we doing with 2 pi or pi. That is what I want us to focus on. And remember, we always want our answers between 0 and 180 at the end. Or if I went back to the rules, if I'm talking about radians, we want it to be between 0 and pi. All right, so as long as our answer is between 0 and pi, we are good to continue for radians. Negative pi over 4, we don't like negatives, so we have to find the coterminal angle, which tells me I need to add a full rotation, and that full rotation is 2 pi, just like in our notes a little bit ago. Well, I have to make it 2 pi over 4, which will now make it 8 pi over 4. So the real angle that I'm talking about is 7 pi over 4. All right, and if you think about that, 7 pi over 4, well, if I added another pi over 4, that would get me to 8 pi over 4, which is 2 pi. 2 pi is close to the fourth quadrant, so if I'm just shy of that, then I know that 7 pi over 4 is going to end up in the fourth quadrant. Again, that is something we will get familiar with as we go through. Just take my word for it now that this does exist in the fourth quadrant. You will get your practice on this actually in the next set of notes. All right. 7 pi over 4, that's in the fourth quadrant. The fourth quadrant tells us to take 360 first, but in our case, since we're talking about radians, we want to take 2 pi and then subtract what we were given. Get the same denominator, and so my reference angle, oddly enough, is a positive pi over 4. And let's continue. 8 pi over 3, well, 8 pi over 3 is more than one full rotation, so we have to subtract a rotation first. Get the same denominators, and that's going to give us 2 pi over 3 in the end. 2 pi over 3, again, is just shy of 1 pi, so that's going to be in the second quadrant. Second quadrant tells me that for my reference angle, I first need to take pi and then subtract the angle I was given. Find a common denominator. And my final reference angle for question 7 will be pi over 3. Last but not least, negative 11 pi over 3. This one's negative. Of course, I don't like negatives, so I'm going to add a full rotation. See what happens. Get the same denominators here. That leaves me with negative 5 pi over 3. That's still negative. I don't like that, so I'm going to add another rotation. This time, let's use purple here. I'm going to make the same denominator, and I'm going to be working with pi over 3 as my coterminal angle to the one I was given. Pi over 3 is actually going to be in the first quadrant this time. And my reference angle tells me that I'm going to, since it's in the first quadrant, I don't have to do a single thing to it actually. So I'm going to get to leave it as pi over 3. First quadrant is really, really nice, so we don't have to worry about that. All right. Now, why are we learning about reference angles? Okay. When we get to section 4.2, which is the next section we're going to talk about next class, I'm going to tell you if we know the first quadrant, there's going to be a total of like almost 80 things we need to memorize on what's called the unit circle. However, if we can memorize 20 of those 80 things, so that's 20 per quadrant, if we can memorize the very first quadrant, we will know every single other piece in the other 4 quadrants. They all match. We just have to pay close attention to the key details with positives and negatives. So if we know 1/4 of our unit circle, we can find the remaining pieces of the unit circle through the reference angles. So we're practicing that here to see how they relate to one another. So for example, if I wanted to talk about question 1, 345 degrees. And this is just an idea of where we're heading next class. So 345 degrees, that exists right here, roughly. Okay, your initial side, and then your 340. So the real degree measure would be right here. That's 345 degrees. But I'm not asking for that reference angle, or for that angle, I'm asking for the reference angle. At the end of question 1, we ended up with 15 degrees. Now, the way that's going to relate, if I were to graph 15 degrees, I would have the same initial side, but it's going to take me into the first quadrant here. All right. By knowing that that first quadrant is technically 15 degrees, I would be able to use the information about that 15 degrees to tell me the information I need about 345. And vice versa. If I know 345, then I will also know my 15 degrees because they are reference angles to one another. I can say the same exact thing about every other question on this page. I'm using the reference angles. Okay? Now, do I expect you to understand this right away, right this second? No. But when we get into our unit circle next class, it'll kind of come together, come full circle, if you will, and we will make some realizations out of this. All right, but for now, when we talk about reference angles, use this first page to help us. If it's ever in the first quadrant, you don't have to do a single thing. It's going to be the same angle regardless. If it's in quadrants 2, 3, or 4, then we have to do a little bit of calculation.